The fourth question is a simple question. If you remember the formulas, we have been given m cells in series, and this one series there are n such rows which are connected in parallel. We need to find out the current through this resistance R and the value of this R for power through this R to be maximum. So for solving this question, we have clearly see that we have to apply the formula for combination of cells in series and in resistance and in parallel. Now for series, we know that if we have E1 R1 in series with E2 R2, internal resistance is R2, then the resultant becomes equal to E1 plus E2, and we have an internal resistance of R1 plus R2. In the case of parallel connection, if we have E1 and we have R1 over here and E2 and R2 over here, then the resultant becomes equal to, the resultant is obtained by, the formula is E resultant is equal to E1 upon R1 plus E2 upon R2 upon 1 upon R1 plus 1 upon R2, and the equivalent resistance is given by simply 1 upon R equivalent, that is the equivalent internal resistance. This will be equal to 1 upon R1 plus 1 upon R2. But this is only when these two are in the same direction, otherwise the formula will change. Now to find out the current I, we need to find out the equivalent resistance, the equivalent internal resistance R equivalent and the equivalent cell E equivalent, and then we can easily find out the current. So for solving this, let us do it for each of the rows first. Looking at the first row, since all the batteries are in the same direction, oriented same, therefore the equivalent cell EMF will be equal to M times E, and the equivalent internal resistance will become equal to MR. Now we will have n such rows. We have n such rows. Now we need to combine these cells in parallel. Now in combining these cells in parallel, since all of these have the same EMF and the same internal resistance, therefore the final resultant will be ME only. You can check it out by the formula also, but you remember this result: whenever cells with same internal resistance and same EMF combine in parallel, the resultant EMF is same and the resultant internal resistance is reduced by a factor of N, that is, it becomes MR upon N. So we now will have, you can check this out with the formula also, a cell with internal resistance MR upon N and with EMF equal to ME, and we have R over here. To find out the current I, we can directly write current I will be equal to ME upon R plus MR upon N, because this is the total resistance in the circuit. Total EMF divided by total resistance is equal to current. So we get a final answer for the current in the circuit to be equal to ME upon R plus capital R plus M into small r upon N. Now we need to find out the value of R for maximum power. Now we had already solved in the previous question. The value of R for which the power is maximum is the value equal to the internal resistance of the cell. Therefore the value of R for maximum power is R is equal to M into small r upon N. So we get a final answer for the current and the resistance for maximum power.